So, good morning to all the dear participants. Uh, First of all, I would like to welcome Dr. S.S. Patil sir for the today's lecture. And before the starting this lecture, firstly, I would like to give a brief intro of Sir Patil sir. So, Dr. S.S. Patil is currently working as a principal scientist in National Institute of Veterinary Epidemiology and Disease Informatics, Karnataka, Bangalore. Patil sir has Patil sir did his BSc from the Karnataka Veterinary College and then completed his MBSc and PhD from the IVRI. Further, sir has served for the National Institute of Higher Security Animal Disease, Bhopal, India, and as a scientist and then thereafter the senior scientist. After the servicing at the Bhopal, sir has also served at the National Institute of Veterinary Epidemiology and Disease Informative for the several years. Sir has also handled the plenty of project, institute funded project 15, externally funded project 10, and sir has also published the 150 papers and the four book edited, the four book have edited and written the 15 book chapters and published the 56 abstract. And recently he has awarded with the National E-Governance Award by the Department of Administrative Reforms, Government of India. So I would like to, on the behalf of all the participant and as a organizing secretary of this 21 days refresher course, sir, welcome you, sir. And I would like to request to start your presentation, sir.
Thank you. Thank you very much for nice introduction about me. I thank Dr. Arun, Dr. Hamida Khanam, Dr. Amruta, and NADCL for giving me an opportunity to speak on this beautiful topic, meta-analysis, a tool to zero in on errors. As I have seen, the majority of the participants, they are either academicians and researchers. And you all know, and you must be handling many of the research projects or formulating the research projects. Before conceiving the idea, if you are selecting and choosing any topic for your research programs, one will definitely always and almost he will be reviewing the literature, either in the electronic media or through journals or some other means of collecting the information. So he will be going through systematic review of literatures, and unknowingly you are doing the meta-analysis. And the only thing is that you have to add a statistical tool to this and come out with a precision of the results so that facts and gaps can be identified, which will lead to formulation of the projects which can fill the gaps in formulating the project of a particular species or the research item. So with this, I will be going through the meta-analysis. What is meta-analysis? Where all it is used, and what are the different steps in conducting the meta-analysis. What does the meta in this meta-analysis means? Itself is analysis. It's an analysis of analysis. Already analysis is done and the literature is available. We have to accumulate and put a statistical tool, and precision of the results can be obtained. So with this, in subsequent slides, let us see how the process of meta-analysis keeps going. Let us see what is meta-analysis. It is a statistical technique used to combine and analyze the results from multiple studies on a particular topic or research question. It allows the researchers to assess the overall trends and effectiveness of an intervention or the strength of associations in observational studies by pooling the data from different studies. That is how you do the systematic review to increase the statistical power and improve the estimates of effect size. You have the literature, you pool them. The study will be pooled together and then effect size will be calculated. So it is used in medicine, psychology, social sciences. In all the fields nowadays, it is being implemented. It helps to resolve uncertainty when individual studies produce conflicting results. We always tend to go to such a study wherein positive results are only published. Majority of the people, they keep the negative results with themselves. And also sometimes the studies which have more number of samples included are also being missed out sometimes. So we have the process flow of meta-analysis, systematically identify the relevant studies, assessing their quality, extracting data, using statistical methods to combine the findings, then that provides more robust conclusions than any single study. So if you look back the history, in 1904, Carl Pearson collected data from multiple studies assessing typhoid inoculation and used a meta-analytic methodology to collate and summarize the results of multiple studies. Then the term meta-analysis, however, was coined by Jean V. Glass in 1976, who is now considered as the father of meta-analysis. And later on, while evolving, many people they have contributed, like Johnny Hunter, Ingram, and one Raju from India, and Jacob Cohen, and so many people they have contributed, and it is slowly evolved into different branches. So meta-analysis is examination of data from a number of independent studies of the same subject. You have to choose one subject, then in order to determine overall trends. It's an important component of meta-analysis is the investigation of the consistency of treatment effects across the studies. You find hundreds of publications on one particular study that you have to put together, and cumulatively you have to take out the heterogeneity and the variance. So systematic review and meta-analysis are the two terms that you might see used interchangeably, and each term refers to research about research. That's what I told, analysis of analysis. But there are important differences also that you will be seeing in subsequent presentation. So Cochrane collaboration, it's an institution, organization where they keep records of all the meta-analysis and the systematic studies done. Once you are done with the meta-analysis, you have to register with them so that they will be useful for the subsequent users or future study researchers. It will be much helpful. So this includes a scientific process where all empirical evidence, practical evidence that fits pre-specified eligibility criteria, they are collated in order to answer a specific research question. That includes systematic identification, selection, synthesis, documentation, evaluation of sorry, original research studies, create a high grade synopsis of a subject. Excuse me. Answers pre-specified research questions accompanied by meta-analysis. Sorry. So meta-analysis consists of applying statistical methods to analyze and summarize the findings of the studies included in the systematic review. Meta-analysis involves detailed scrutiny and analysis of a large body of published studies or other literature. Meta-analysis allows quantitating global effects or findings rather than relying on one results from isolated studies conducted under specific conditions, for example, in a particular region. So you have to gather more and more number of the studies, at least 10 or more. What is the rationale of systematic reviews and meta-analysis? It conforms to the scientific method. It is a scientific method which requires findings to be replicable, to be believable. No individual study, no matter how large, constitutes proof according to the scientific method. So you need not to depend on single study that gives erroneous results. Systematic review and meta-analysis provide structured guidance in an environment with ambiguity or abundance of data. Thus, they are frequently accepted by high-impact journals and cited. For example, I'll be showing the meta-analytical studies published in different journals in subsequent slides from our institute also. High quality meta-analysis provides an overall impression of the extent, nature, and type of evidence relevant for a particular research question. In highlight, it highlights the gaps in the literature, as I told earlier. You have to find out the gaps, and it enables the aggregation or pooling of the results, and it statistically integrates the findings of multiple studies. Hundreds of studies are there in the data available. In the era of data, we have electronic media which provides you lot many information about the studies on a single topic or a single agent or single disease, and provides new and useful evidence. Hence, they are ranked at the apex of the evidence-based pyramid. The Cochrane collaboration, it's an institution organization that has advocated this approach and published guidance. There are set guidance which we'll be seeing in the subsequent presentation slides for a systematic reviews and meta-analysis, and published the statement of for the preferred reporting items for systematic reviews and meta-analysis. That is called PRISMA. You have to provide as a supplementary material, or you have to include it in your meta-analytical manuscript itself. PRISMA is the guideline that we will see in subsequent slides in order to enhance the reporting of systematic reviews and meta-analysis. There are two types of meta-analysis: aggregate meta-analysis, aggregate data meta-analysis, and individual participant data meta-analysis. Aggregate data analysis, it utilizes the summary of the published data, for example, the study reports. It combines the data at the study level from summation statistics described in each study. It takes mean, sample sizes, and standard deviations, and limited. It has a limitation limited by the quality and consistency of the reporting in the original publications. Whereas individual participant data meta-analysis, it is a resource intensive because you have to concentrate on individual data, and to obtain the data related to the individual study or individual patient or individual animal, you need to put lot of efforts and put lot of resources to obtain or retrieve from the literatures. It's a more complex as compared with the ADM meta-analysis. It can be more consistent and answers the questions more thoroughly because you are working on the individual data analysis. It allows exploring data more thoroughly and likely provides more appropriate analysis. So in the era of evolution, the meta-analysis also evolved, and now we have the NMA, network meta-analysis, multiple treatment meta-analysis, or mixed treatment comparisons meta-analysis. And we have another one is non-inferiority meta-analysis. So NMA, it combines direct and indirect evidence. Simultaneous comparison is there, more precise estimates, and addresses limitations of pairwise meta-analysis. And the benefits of NMA are comprehensive comparison will be there, answers clinically relevant questions, and facilitates decision making, identifies important questions. Whereas NI meta-analysis, it combines evidence from studies, including non-inferiority trials, which are of high standards sometimes or low standards, to assess whether a new treatment is not much worse than a comparator treatment. These analyses are crucial for understanding the real-world effectiveness of treatments, especially when direct comparisons are not possible or ethical. We cannot go and do it in the field. So advantages is NI meta-analysis can provide more comprehensive understanding of the treatment effectiveness. Disadvantage is it can be more complex to design and conduct. Their interpretation can be challenged. So meta-analysis, as I told in the introduction itself, you are doing already, but only thing, use of statistical techniques will further help in coming out with the precision of the results. So it is like any other study. It is as follows the same principles as primary study, where the unit of analysis is a study rather than a patient or a community member. So it should have a clear aim or set of aims, recruit studies in such a way that the available data are completely enumerated. At least the studies included are representative of available data and be analyzed appropriately. Assumptions tested should be there, and reporting should be factual and limitations described fully. So this is a step-by-step guide for conducting meta-analysis. Step one, there are 10 steps. Step one is follow available guidelines like PRISMA guidelines that I will show in the next slide. preferred reporting items for systematic review and meta-analysis checklist. Step 2 is formulation of a specific research question. PICO and PECO is there. And step 3 is study eligibility and defining the inclusion and exclusion criteria. Now we have ended up with hundreds of literatures. All hundreds cannot be included in your study. There are some gaps. So how to exclude them? How to what all the literatures can be included? You have to have the criteria for inclusion and exclusion of the literatures. Step 4 is databases and article sources. Step 5, performing the literature search and screening, data extraction, assessment of data quality, data synthesis, in that selection of meta-analysis model, and post hoc analysis of findings specific to meta-analysis. Another subgroups are there: subgroup meta-analysis, sensitive analysis, heterogeneity, publication bias, and so on. And there are available free softwares, strength of evidence, and writing a meta-analysis. 10 steps. We can go on step-by-step analysis. Step 1 is follow available guidelines. Systematic review and meta-analysis must be written in accordance with the PRISMA checklist 2009. So the way it is written, it is shown in next slide. In the past, quality of reports of meta-analysis of randomized controlled trials, that is quorum, and meta-analysis of observational studies in epidemiology, that is MOOS, statements were used. Now they are overcome by systematic review and meta-analysis. Cochrane is an institution or organization. It has developed guidelines for conducting the meta-analysis for clinical studies. Step 2, formulation of a specific research question. The most important step is you postulate a specific research question or hypothesis. How to go about? What should be taken into consideration? Then you follow the PICO, and model should be used when applicable: population, intervention, comparison, and outcome. Then for observational study of etiology, I is replaced by E, that is exposure. Population, exposure, control, outcomes, and model can be used. Step 3, study eligibility and defining the inclusion and exclusion criteria. Now you are ended up with nowadays data. Data is data everywhere. In all the media it is available, and especially the electronic media, we get, if you put some search items, you'll get hundreds of reports on that. The PICO approach is used to define the eligibility criteria. Thereafter, exclusion and inclusion criteria should be defined to minimize the risk of selection bias. You cannot include all the results, whatever are available in the data in an electronic database. Examples of exclusion criteria are published published duplications, unavailable full text, papers not published in peer-reviewed journals, or abstract-only papers. You have to exclude them. Inclusion criteria, they include the articles which contain the required information. Both positive, negative results or answers, they should be included, relevant to your research question. Whatever the research question you have coined before starting the meta-analysis. The researchers need to create a balance of only including quality evidence, but not excluding relevant studies, such as unpublished but well-conducted clinical trials are there. There are some people, they are afraid of getting their results rejected. They will be keeping in the drawers, but upon request, if you know them, they will be providing the information for inclusion in the study. Step 4, databases and article sources. High quality meta-analysis involves careful search of the literature that identifies studies in multiple languages. There are some Korean languages and some Dutch language. If requested, they will be translated and given to you, and from both published and unpublished resources. The most important sources are electronic databases. Nowadays, it is very easy to access them. The database selection predominantly depends upon research questions, since most databases sources studies from particular types of the journals. We have the keywords, use the Boolean words also, and systematic search utilizing electronic databases that can include the following are PubMed, Web of Science, Science Direct, Scopus, Embase, and Google Scholar. They are free softwares available in all the electronic media. Step 4 continues. at least two databases must be searched. If more than two also is fine. Larger the number of the databases searched, greater will be the yield of the results and data will be more. And in keeping with the recommendations of the Prisma statement, every meta-analysis should provide at least one complete search strategy for one of the major databases in the supplementary file. In a flow diagram, you have to provide so how the search methodology was followed. Databases, searches should be augmented with manual searching of references. It's very difficult nowadays. Earlier were those days wherein cabby abstracts used to be there and cards used to be there. We used to go and collect the abstracts manually from the identified studies. Now it's very difficult. Or reviews, screening related articles in PubMed and Google Scholar, and further complemented by contacting the study authors and the subject matter experts. If at all it is very much required, you can contact the corresponding author. They will provide you the full details. Other potential sources of relevant articles include published conference abstracts. This is one important information is that they will come out with the compendium and it will be available in the Google Scholar or in the internet. They will air the compendium in the internet sometimes. Sometimes if it is not available, at least one abstract you can trace back the organizer and they will provide you the soft copy of the abstracts. And they are very useful information because students, the teachers and the professors, they all will be publishing abstracts in conferences. A comprehensive literature search should include other sources, for example, handbooks and manuals pertaining to the relevant topic, graduate thesis, and dissertations. These are important sources of the data. And finally, those conducting the systematic review and meta-analysis should contact the corresponding authors for the missing data, as I told earlier. And the Prisma study diagram refers to these data in the category records identified through other sources upon request if it is provided. Step 5, performing the literature search and screening. As I told, key search items are there. They are developed to incorporate free text terms. For example, words in the heading or abstract. If you put it in the internet, you will be getting the full paper or the abstracts, which upon request, you will be retrieving the full paper, this one. And any other subject indexing like medical subject headings, MESH, likely to require additional studies. Get help from a librarian or an expert in the topic of interest. This is again, it is becoming obsolete. Nobody goes to the library nowadays. Everything is available in the database. If any foreign language like Dutch, Korean, Chinese, if they are there, then librarian will definitely help to get the full paper in English. Finalize appropriate databases. Then literature search can be performed by linking the search terms using the Boolean operators like and, not, or. So they will be used. Then further refinement or the more detailed literature can be obtained. Then screening steps. Screening the title. So after mere reading the title, you get an idea. So if your interest of topic interest is there in the title, so then go to the abstract. Read the abstract carefully. Sorry for the interruption. Abstract to identify the relevant studies and include or exclude those that are unsuitable for your systematic review. Downloading full text and then screening these based on the predefined inclusion and exclusion criteria. Now, almost ICR has subscribed to so many journals. We have one nation, one subscription. So almost all the papers now can be downloaded with the IP addressed ICR institutes and NAR system also. So at least two people should independently select and screen the studies to avoid the biasness of the selection of the studies, to minimize the selection bias, and any disagreement should be resolved by mutual consensus. So coming to the step 6, data extraction. The subsequent step in which should also be done by two independent people. Then extracted data should be collated in an electronic data extraction. That is the best one is Excel sheet. So you start enumerating in the Excel sheet, start collating, and then you will get an idea, and should be done in accordance with the research protocol. So Cochrane reviews have outlined the minimum data that should be retrieved from each article. So that you tabulate, you decide what all the data to be included in your systematic review first, and then going for the meta-analysis. Assessment of data quality. The studies included in the meta-analysis should be assessed in relation to the quality and risk of the bias. Biasness is the one major uh, component of the literatures, which should be removed after accumulating many of the data. The quality of evidence reflects the degree of confidence that estimate of effects is correct. The quality assessment of the studies is important to determine if a particular study should be included in the meta-analysis, or differential weighting of the study should be given. That we have to decide using taking the help from the statistician. The assessment of the study quality is facilitated by standardized appraisal tools, and several tools are available that can be utilized to assess the quality of the studies that are to be included in the review and meta-analysis. The most commonly utilized tools are Cochrane Risk of Bias tool and Newcastle-Ottawa scale. Cochrane Risk of Bias tool is frequently used for evaluating the quality of randomized controlled trials, and Newcastle-Ottawa scale is used for evaluating the quality of non-randomized this one, cohort studies and case control studies. Coming to the step 7, assessment of data quality, that continues. The steps involved in evaluating the risk of bias and quality of the studies that are to be included in the systematic review are identical to those involved in selecting the studies and abstracting the data. Quality scores that provide a single number exist, but might be helpful, unhelpful, or even misleading. So more the number of the scores, that better will be the study. A more appropriate approach would be to assess independently the specific domains of the quality assessment tools and outline the studies that do not attain the defined quality standards, rather than focusing on the overall scores. So one has to be careful while assessing or assigning the scores to individual studies. Furthermore, a sensitivity analysis can be performed by leaving out the studies that fall short of the quality standards to evaluate the effect of overall results and findings. Step 8, data synthesis. Data can be synthesized either qualitatively or quantitatively. So you have to decide what type of data you have to synthesize. The statistical analysis of effect sizes is the main domain of the meta-analysis. Effect size is one important factor in the study. So it is more concerned about understanding the effect sizes and not on testing of the hypothesis. Here we are not coining any hypothesis of the study. Our aim is to collect more and more literatures on a particular subject. The term effect size can mean many things in different contexts. The Cochrane Handbook describes 3 common methods to measure the effect size, which quantify either the difference in some measure between groups, or the degree of correlation between numeric measures. If you are taking positive and negatives of a particular prevalence studies, that you have to categorize separately. For dichotomous data, yes or no, or binary outcomes, the most commonly used methods include the risk ratio, that is commonly relative risk, and the odds ratio. Binary data means only 2, yes or no, present or absence. The primary aims of meta-analytical approach in relation to the effect size are to evaluate the size of the effect, evaluate the direction of the effect, assess if the effect is constant across all the studies, determine if there are any patient or study design characteristics that influence the effect size or direction, and evaluate the strength of the evidence of the effect. Data synthesis, again continuity. The core of a meta-analysis is the calculation of a weighted average of the individual study effect size. You have to be, you have to calculate very carefully. This is often referred to as the pooled estimate, and it is critically important that studies and the effect size measures being pooled in a meta-analysis are comparable. The concept of weighting, giving weightage suggests the statistical reliability of any given study. A frequently used and a simple version of the meta-analytical approach is often referred to as the inverse variance method. Variance is there and inverse of the variance, and the inverse of the variance of the effect estimate is most commonly used for weighting the studies. Hence, larger the studies with smaller standard errors are given more weightage as compared with the smaller studies with the larger standard errors. So this makes sense since the larger standard errors indicate poorer statistical reliability and vice versa. We all know that. Selection among weighting systems. Meta-analysis utilize either the fixed effect models or the random effect model. There are two types. So fixed effect model assumes that the effect sizes only vary across the studies due to random sampling differences. And this meta-analysis studies similar populations and use the same variables and outcome definitions, and hence observed differences between the effect estimates of the studies are potentially explained by random sampling errors. Whereas the random effect models that allow the possibility that there are systematic differences between the effect sizes estimated from the different sizes. So it is preferred model as it counts for both the random sampling error and systematic between study variance. So majority of the time we go for the random effect models. Heterogeneity is one of the important criteria in almost all of the studies or literatures. Wherever you are collected, you have to be very careful while taking the heterogeneity into consideration. Any kind of inconsistency among studies in meta-analysis may be labeled as heterogeneity, and it is essentially to rigorously assess for and describe the data heterogeneity. Excuse me. There are three different types of heterogeneity: clinical heterogeneity, variability in outcomes studied, the participants or the interventions, variability, methodological heterogeneity. This is the most common because it's a variability in the risk of bias, study design, or outcome measurement tools. Then statistical heterogeneity, again, we have many tools. The application of the tools is very important. Variability in the intervention effects, which can be result of either clinical or a methodological diversity or both among the studies. Yes, there will almost always be some variation. As I told, variation will be there between the studies in estimated effect size, even if this is only due to random sampling variation. So whether variation observed is beyond what random sampling might yield is typically evaluated with Q statistics and measured using I-square measures. Interpretation of the I-square statistics in the context of meta-analysis are: we have 0 to 40% might not be important, 30 to 60 very represent moderate heterogeneity, 50 to 90 represent substantial, and 75 to 100% heterogeneity, it is a considerable heterogeneity, what we can say. So sometimes the reviewers, they reject based on the too much of heterogeneity in your study. So there are biases, recall biases, and also biases in various ways. So meta-analysis are based on aggregation of evidence from previously published literature and studies. We all know, we have been doing that. Results of the meta-analysis can be influenced by the papers that may have been missed. So we have missed, we could not retrieve them, but they were having the important content and information about the information, but we have missed it. That may add to the biasness to the meta-analysis. Large studies with positive outcomes are more likely to publish as compared with, we all know, we are as a researchers, we do the sampling methodology. We collect so many samples and come out positive, negative. More positive means we are thrilled because it is likely to be getting accepted by the journal reviewers as compared with smaller studies with negative or non-significant results. Negative result is also a good one. In a selected population, if the samples are negative for particular disease or in agents, then it's a good information. That also should need to be published. And some journals they accept such methodologies also. Publication bias. Small study effects is the inclination to publish only the results are statistically or clinically significant. Sometimes they will be keeping with themselves. The related bias is known as the file drawer problem, where the researchers have the data which were never even submitted for publication because they expected it to be rejected. So such biasness will also be very much influential. Publication bias can be addressed. So we need to address by utilizing multiple statistical approaches such as Egger's regression, trim and fill procedure, funnel plot, and fail safe N. Most commonly used is, so please bear with me, the funnel plot. It is commonly employed method because it's easy also and it is visually very much helpful. It provides a graphical evaluation of the potential for bias and was developed by Light and Pellman, discussed by Ecker and colleagues. Since the plot gives a visual relationship between the effect size and the standard errors, its interpretation is subjective and is only interpretable when at least 10 studies are available. Better, more the number of the studies, better will be the visualization. In the absence of publication bias, the funnel plot is likely to resemble a symmetric inverted funnel. The appearance of the funnel plot here, you can see uh, the scattered dots. They are more having more heterogeneity than the one near to the tip of the funnel. Hmm. So these are different funnel plots. You can see the top one is symmetrical plot in the absence of bias. It's a I can say it's the optimum one, and middle one is asymmetrical plot in the presence of publication bias, means smaller studies showing no beneficial effects, and the bottom one is asymmetrical plot in the presence of bias due to low methodological quality of smaller studies. See, open ones are there and the filled one dots. Open circles indicate the small studies of inadequate quality whose results are biased towards larger beneficial effects. Egger's test, which helps in commonly used statistical test to detect funnel plot asymmetry. And funnel plot asymmetry symmetry is reassuring because random chance should work in both the directions, and asymmetry suggests non-random forces at work and hence potential for selection bias. So there are many types of the bias: publication bias, time lag bias, language bias, citation bias, where citation or non-citation of research findings depending on the nature and direction of the results, multiple location bias, selective reporting bias. Uh, when you have collected more number of the information, and within the information, if it is very unlikely to analyze. So in that aspect, you can go for the subgrouping of the main groups. Subgroup and meta-analysis analysis must be performed if only sufficient studies are included in the meta-analysis to potentially examine the effect of explanatory variables, effect modifiers, or covariates on the outcomes of the interest and thereby explain some or all of that variation. It involves splitting the studies into subgroups and performing simple meta-analysis within each stratum. That will give more much clear information. Subgroup analysis can be conducted for subsets of the study subjects or subsets of studies, like studies utilizing a specific diagnostic set test that can be grouped separately. If you are taking PCR, if you are taking ELISA, then if you are going for the qPCR, so you can divide or subgroup based on the diagnostic test used. Subgroup analysis can be done to investigate heterogeneous outcomes or to answer a priori questions about study groups, types of the interventions or types of the study. In clinical trials, the subgroups can be divided based on the interventions made. So meta-regression, it takes this idea further to allow the effect of continuous as well as categorical characteristics to be investigated, and in principle it allows the effects of multiple factors to be investigated simultaneously. So it should be ideally conducted when there are at least 10 or more studies in a meta-analysis. Meta-regression uh, should be conducted when there are at least 10 studies. Sensitivity analysis. It involves the repetition of the main meta-analysis in which different results or conclusions or ranges of values are replaced for choices that were subjective or otherwise open to debate. It is different from subgroup analysis in the sense, unlike subgroup analysis, it analyzes the analysis do not attempt to estimate the effect of the intervention in a subgroup of the studies that have been subtracted or removed from the primary analysis. It analyzes sensitivity analysis also allow informal comparisons between various ways of calculating the same thing, while in subgroup analysis, statistical evaluations are made across the defined subgroups. It is different from the subgroup analysis. So while theoretically systematic analysis can be done manually or utilizing the standard software, including the most popular one is the Excel. Then we have SPSS, we have SAS also, and they are either within the structure of a statistical package such as Stata package is there, R program, which is commonly and it is taking a big leap in data analytics, and standalone applications such as comprehensive meta-analysis, CMA platform, and Cochrane Ravman, they are available. The software packages vary in terms of their cost, statistical models, user interface, and graphical output. So you have to be very careful in selecting the softwares. Assessing the quality of evidence. This grading of recommendations, assessment, development, and evaluation. It's an instrument that most recognized tool for assessing the value of systematic reviews and meta-analysis. It rates the overall quality of the evidence as very low, low, moderate, or high. And it accounts for two types of the studies, that is observational studies or random clinical trials. As per a grade, the evidence is initially set to high for RCTs and low for observational studies. Five criteria you should include while grading: risk of bias, imprecision, inconsistency, indirectness, and publication bias. Using grading of recommendations grade instrument to define the quality of the evidence. High quality means further research is very unlikely or change our confidence in the estimate effect. Moderate quality, further research is likely to have an important impact on our confidence in the estimate of it, right? And may change the estimate. Low quality, further research is very likely, and very low means an estimate of effect is very uncertain. So step 10 will be writing up meta-analysis. A systematic review with meta-analysis follows the same format like as an original study, including introduction, method, result, discussion, and conclusion. In addition, most scientific journals require the authors to provide the Prisma checklist and Prisma flow diagram either as a part of manuscript or as a supplement material, as I told earlier. Finally, consider registering the systematic review in an international prospective register of systematic review. What I told earlier, because it will be an asset to the future researcher, or it will be helpful to many people, which is an open access online international register of systematic reviews with health related outcomes. The main aim is to reduce duplication of systematic review. If it is registered, it will give an idea already it is done. So change the topic, allow transparency in the review process, and thereby minimize the reporting bias. Yeah, this is the Prisma checklist. As I told earlier, we have the section like title, then abstract, introduction. In the introduction, you can go for the rationale and objectives, methods, protocol and registration, eligibility criteria, information sources, search, study selection, data collection process, data items, risk of bias, summary measures, synthesis of results, risk of bias across studies, additional analysis, and then come to the results and discussion. So you have to, in the results, study selection, study characteristics, risk of bias within the studies, results of individual studies, synthesis of results, risk of bias. Then in discussion, you have to write about the summary of the evidence. Then limitations. What are the limitations in your study itself? You have to mention them. Then conclusions and funding of the study. You have to mention about that. This is the Prisma flow. You have to divide your study into three, four: identification, screening, eligibility, and included or excluded. So identification, records identified through database searching, how many records you have to mention there. Additional records identified through other sources other than the on personal communication, you might have got some records that you have to mention. Records after duplicates removed, how many, records screened, how many, and records excluded, how many, and full text articles assessed for eligibility, how many, articles excluded, how many, and now tapering on to the studies included in qualitative analysis, qualitative synthesis, studies included in quantitative synthesis, meta-analysis. You have to narrow down the number of articles included in the study. Writing up a meta-analysis, it is generally demonstrated using a forest plot. Forest plot illustrates the effect size estimates and confidence intervals. Each study is depicted by a point estimate of intervention effect with the horizontal line that I'll be showing the next slide, the picture, and the size of the block, confidence interval. Then the studies with similar, smaller confidence interval also shown. Then the discussion of meta-analysis should be highlighted. So this is how a forest plot looks like. Like you see the weightages, study 1, 2, 3, 4, 5, 6, like it goes on. You list them. What are the events, total, and intervention control within that events and total, and the weightage is given, and the risk ratio is this, weight for the study, statistical significance, heterogeneity, and overall test. We have the weight for the study, overall effect estimate and confidence interval is given, and effect estimate method, model, and confidence interval, and effect estimate and confidence interval. Each study is given here. Effect estimate and weight for each study, overall effect size. We have here, yeah, maybe in the next. Yeah, limitations, we have certain heterogeneity of the studies, publication bias, quality of, you have to mention and you have to explain each limitations in your conclusions also, and quality of included studies, data availability and reporting, statistical limitations, then lack of standardization, time lag bias, and overemphasis on quality, quantitative synthesis. So conclusions, we have now data everywhere, data on epidemiology and risk factors for the diseases, effects of various size, systematic review. We have many, and how best we can utilize them, we have to think on that. It's an meta-analysis is important. There it comes as a research tool, well accepted method to synthesize, accumulate, analyze the research findings. and it has its own limitations, as I told. Majority can be addressed carefully by formulating the research question or hypothesis of a systematic review and applying a correct statistical meta-analytic approaches. There are many tools. We have to select such a tool. Best fit model can be used to analyze the results. Conducting a high quality publishable meta-analysis is a sophisticated task that requires specific knowledge, dedication, and commitment. Rewarding to understand the challenges involved in conducting systematic reviews and meta-analysis, since the insight generated with the properly conducted is more than the sum of the parts. These are some of the publications from our institute. We have published many articles based on the using meta-analysis. A systematic review and meta-analysis on the prevalence of infectious diseases of duck. It's a very exhaustive and detailed information on the disease of the ducks. Prevalence of livestock diseases in northeastern region of India. Meta-analysis of classical swine fever. Prevalence in pigs in India, 5-year study. We have taken the period fixed as a 5-year, and the number of the studies are more in that. Prevalence of ESBL, systematic review, another one. And another one is basic reproduction epidemiological tool for prioritizing livestock diseases. Karnataka example we have taken. And global status of major pathogens of milk concerning bovine mastitis, a systematic review and meta-analysis. And countrywide prevalence of subclinical and clinical mastitis in dairy. The subject chosen is mastitis here. And we have done on bovine mastitis, bovine babesiosis, an insight into global perspective on the disease distribution by systematic review and meta-analysis. Theileriosis prevalence in cattle and buffaloes in India. The topic here is theileriosis. The species are cattle and buffalo. And we have done a PPR in atypical host and wildlife. And prevalence of JE virus in mosquitoes and animals of the Asian continent. You can geographical region, you can fix it. Take India as one unit, or the continent per se as a one unit, or you take as a global survey. If you take global survey, that becomes too much of information. If there are limited studies on particular like Kashmir forest disease, then the information will be very less. The prevalence of methicillin resistant Staphylococcus aureus in India. So FMD prevalence in India, again systematic is on prevalence of brucellosis in livestock in African and Asian continents, limited to 2 continents. In sheeppox, goatpox in Asia and African continent. Then gastrointestinal parasites in pigs in this one. Yeah, again bovine babesiosis in India, taking India as this one geographical region, and comprehensive assessment of LSD in African countries. That is one more continental study. I should acknowledge the majority I have taken it from the papers published. This one, my director I acknowledge. Yeah, thank you very much. This is in a nutshell about this one. If you have any questions, I will try to.
Okay, if no, is there any question from the participant side? Anyone have any query? Okay, if no question, then let me continue regarding the thanks regard. Sir Patil sir, thank you very much for accepting our request, for delivering such an valuable and informative lecture to our participants. Thank you, sir. I think that participant must be benefited and with your this informative lecture. their knowledge regarding the meta-analysis must have been updated. So thank you very much, sir. And if any question is there, we will share your presentation with the participants. And if any query is there, with your kind permission, they will contact you in person if they have any query regarding this presentation.
Sure, sir. We have a team here, a group of people working on meta-analysis, and definitely will